5 to make sure you're ready for quiz 3 from chapter 10. Okay, number 1 is a circle with 2 chords. Whoops, that's not an 8. It's a 6. And there's an X down here, and an 8, and a 9. Okay, and you're to use the segments of chords theorem, which says that when you multiply the segments of each of these chords together, it will equal the same product of the other. So that would be 6 times x, or 6x, equals 8 times 9. 8 times 9, which is 72, equals 6x. Divide both sides by 6, and you get x is equal to 12. Okay, going on to number 2. You're going to use number 2 is another circle. This time we have secants because they go outside the circle, and whenever you have lines that intersect outside the circle, the part times the whole segment is equal to the part times the whole. So this is the segment of secants, part. Let me try it with a different color so it's more clear since I have circles. Part times whole is equal to the part times the whole. So that would be 7 times, the whole thing is 7 plus 5, or 12, is equal to 6 times, now this one is going to be a little bit different, 6 plus x. Okay, so 7 times 12 is 84. Using the distributive property, 6 times 6 is 36 plus 6x. You move your 36 to the other side. You get 48 equals 6x. Divide by 6 and you get 8. X is equal to 8. Okay, and going on to number 3. Remember, you can stop this recording at any time. Go back and look at something you didn't quite get so you can hear me say it as many times as you need to hear it. Okay, 16 and x and 12. This time you're going to use the segments of tangents and secants. Really, it's the segment of secants because this is really, change the size of this thing. Okay, this is really both the partial, the outside part of the segment, and the whole. And so the segments of tangents and secants says the part times the whole, part times the whole is equal to the tangent squared, or the part times the whole again. It's the same thing. Okay, so 12 times x is 12x equals 16 squared, which is 256. And then you divide both sides by 12. I'm sorry, that's not 12 times x. It's 12 plus 12 times 12 plus x. I apologize. Hmm, 12 times 12 plus x, because it's got to be the part times the whole. So we get 144 plus 12x on this side is equal to 256. And then you take 256, subtract 144, and you get 112 equals 12x. That's a weird looking 256. Divide both sides by 12. Then you get x equals 112 over 12. So let's see what we can divide by to simplify this fraction. We know we can divide both of them by 2. So 2 into 11 goes 5 times. So that's 56 over 6, but it's still divisible by 2. And so 56 divided by 2 is 28 over 3, 28 thirds. Okay, moving on to number 4, we're going to practice writing equations. And you want to remember that the formula for a circle, you want to practice drawing circles, sorry about that. Use the information given to write the standard equation circle, so you are writing your equation. Okay, remember that the circle is x minus h squared plus y minus k squared equals r squared, where h and k, hk, is the center of the circle. Okay, so that's kind of like it coincides with x and y for the center of the circle. Now the thing you have to watch here is the negative here, because your center is going to be the opposite when you put it into the equation. So the center of the first one is 1 and 4. And those are both positive. So when you put that into your circle equation, you're going to get x minus 1, so that it's positive here, but it's negative here, plus y minus 4 squared. Don't forget the square. That'll mess you up if you miss that. And the radius is 6, so it's equal to 6 squared. Now then you need to finish by writing that as an actual square. So don't forget to square that. You don't have to square the rest of them unless it were to ask you to put it in a different format. Okay, the next one, the center, is 5, negative 7. And the radius, it says a point on the circle is 5, negative 3. All right, now what you're thinking here is if you were to put this on a coordinate plane, we'd have 5, negative 7 is the center, and 5, negative 3 is on the circle. Now these are in a straight line above each other, right on top of each other. So that means this has got to be a radius right here. And so it's real easy for you to tell what the radius is. What is the difference between negative 7 and negative 3? It's 4. So the radius here is 4. Okay, now let me erase so that I can make some space here. Whoops. Okay, so we know that 5, negative 7 is the center, and the radius is 4. So you would write x minus 5. It's positive here, so it's negative in the equation. Positive right there, negative right here. Plus y plus 7. It's negative here, so it's going to be positive there. Is equal to r squared, which is 16. Okay, for this next one, I've got to get a piece of graph paper. It says the diameter of a certain tire is 24.2 inches. The diameter of the rim in the center is 14 inches. Draw the tire in a coordinate plane with the center at negative 4, 3. Write the equations at the outer edge of the tire and for the rim where the units are measured in inches. Okay, so I'm going to get a piece of graph paper here. All right, and I've already marked it out to be, the squares are in 6s because we've got a pretty big diameter of 24.2, which means our radius is going to be 12. And so we needed some space there. That's 3 squares on my graph paper. Okay, so let's find the center first. It says that negative 4, 3. Well, since this is negative 3, then negative 4 is going to be 1/3 of the way across there. So negative 4, 3 is going to be right there. That's the center. Now, I would suggest that you use your compass to draw this, but I can't, so that's just the way it's going to be. Now, then it tells us that the rim, the diameter of the rim in the center is 14 inches. So that's a diameter. So to get the radius, you cut that in half, which is 7. Okay, and we have right here to the y-axis, we have 4, and 3 more is 7. So we just have to count off 7 in each direction. Okay, so going up, we have 3, 6, 7. That's about where 7 is. And then going to the side, we have 2, 5, 7. The reason I did that is because I'm right here at 4, To get to 6, I have 2 more. And then I needed to get some more. 2 plus 3 is 5, plus 2 more is 7. Okay, and then going down, I've got 3, 6, 7. And that just makes sure that I'm going through my circle the right way. And you should be able to use your compass. I can't really use it on the iPad. They don't have an iPad compass yet. That's not too bad, actually. Okay, and then it says that the radius of the tire itself is 24.2. And when you divide 24.2 in half to get the radius, you're going to get 12.1. Okay, so we're going to go 3, 4, 7. 7 and 3 is 10. 10 and 3 would be 13. So we're going to go 12.1, which is about there. Okay, and starting at the center again, 3, 6, 9, 12.1 is a little bit beyond the line, not very far. Okay, and then starting back at the center again, I have 2, and 3 is 5, and 3 more is 8. 8 and 3 more is 11. 12 is going to be just beyond here. And then 3, 6, 9, 12, and a little bit more. And so here's the outer part of the tire. Okay, so then it tells us to write the equations of the two. So for the rim, the circle of the rim then would equal x minus, okay, our center is at negative 3. So it's got to be positive, x plus 4 squared plus y minus 3. We're going to use a negative there because the center is at negative 4, 3. So whatever the center coordinates are, they're going to be opposite in your equation. Is equal to, and then just take your radius and square it. Our radius here was 7. So 7 squared is 49. Be careful not to say squared is the same thing as doubling and come up with 14. Okay, then for the tire itself, the beginning of it will be exactly the same because the center is the same for each of them. But then you're going to take 12.1 and square that. And that's going to be 140 something. 146.41. So we get 146.41. And then we have x plus 4 squared. That says 4 plus 4 squared, doesn't it? See, I can do it on here at home. Okay, so we've got x plus 4 squared plus y minus 3 squared equals 146.41. Okay, and that should get you ready for your quiz. Okay, we're in 10.5. I'm just going to go over some selected exercises from the last few assignments. Okay, in number 4, I'm just going over the assignment that you did in number 4. In number 4, you have a circle with a chord and a tangent, and we have 117 labeled as the angle. And you should know that since this is an inscribed angle, it's going to be half the length of the arc. And so the arc is going to be twice that, or 234. This is number 4. Okay, you also had to do number 8. Okay, number 8 looks like this. X, 122.5 and 45 degrees. Okay, now the problem with this problem is that the equations you have say add up these arcs and divide by 2 and you'll get these angles right here. Boy, that's a really fat highlighter. That was weird. I wasn't expecting that. Okay, if you average these two arcs, you're going to get this angle. But the angle that you have is on the outside. So you've got to find what the angle on the inside is. So you're going to say, since that's a straight line all the way over, 180 minus 122.5, which gives you what, 57.5? Okay, so now we know that that inside angle is 57.5. Now we can average these two arcs to find out what this arc is. So we're just going to write it just like you would average them. Okay, it's this arc plus this arc, x plus 45, divided by 2. And I write it this way because it's much easier to see what you need to do. Equals 57.5. Multiply both sides by 2. And we get 57.5 times 2 is 115. And then on this side, the 2's cancel, so we have x plus 45. Subtract 45 from both sides, and we get x equals 70. Okay, so number 10. Okay, now this is a couple of tangents. Whoops, that needs to be a tangent. Touch. There we go. Okay, so we have the x, which is the angle, and then we have 247. 247 is the other arc. So since we don't have any other numbers, we look like we're kind of sunk. But since this is touching right here and they are tangent, you have to do 360 minus 247 to find the other arc. Minus 247 is equal to 113. So this is 113. Now, since our two segments cross on the outside of the circle, we know we have to subtract these two arcs and then divide by 2. So we set about doing that. 247 minus 113 divided by 2 is equal to x degrees. That's 134 divided by 2. Excuse me. $67. And that was number 10. A glass of water. All right, so then we have number 16. It says find the value of 150. We did this one in class. So you've actually already seen this one. So we're not going to do that one. All right, number 18. A, B, 40 degrees, 3x, and 7x. This one is actually much easier to do than it looks like it is. Okay, since our segments are crossing on the outside, we know we have to subtract these arcs and divide by 2. So we subtract 7x minus 3x, divide by 2 equals 40. Now you may start thinking, okay, I need to multiply both sides by 2 or whatever. You don't have to though, because 7x minus 3x you can do. You don't always get the opportunity to do that, but you can this time. And then you can cancel this 2 with the 4 above it. So you have 2x equals 40, so x equals 20. Problem is, that the problem doesn't ask for x. It asks you to find the arc CD. Well, this is A, B, C, D. Arc CD is this one. But the easy one for you to find is this one, because you can do 7x plus 3x is 10x, and 10 times 40. 10 times 40. Oh, I'm sorry. Yeah. 10 times 40. Oh, 10 times 20. Sorry. 200. I don't know why I was saying 40. So that's 200. And if this one is 200, then the rest of this has to be 160 because the whole circle is 360. So the measure of angle CD is 160. Okay, and what else did you have? You had the proof on 28. We'll go over that. Okay, this proof is actually kind of fun to do, I think. All right, it says you have this circle. Now, if you were in class to do this, you're much better off because I could really help you. I really want you to stop the video and think about what I'm saying. Don't just run straight through it. See if you can figure out what you're to do. Okay. So you should have drawn the figure, and you should have given A, C, and BD intersect. And what you're supposed to prove is that angle 1, angle 1 is equal to 1/2 the measure of DC plus the measure of AB. Okay. So, of course, you write the given statement because you already know that. And then you're probably looking at that saying, I have no idea what else to do. Okay, so let's look at what we know. I always say mark everything you know. You know AC intersects BD, but that doesn't really tell you anything. There's nothing to mark on the figure. You can see that it does. So what you need to look at is the 1/2 here. Okay, look over at your figure. Do you have anything on that figure that says anything about 1/2? Because you're going to have to find a way to get that 1/2 into your statements. You got to be able to say something that gives you 1/2. So study the figure. And go through your theorem list. And look through your theorem list for something on the theorem list that states something about 1/2 that has to do with circles. Now you may find this one that says if you have a tangent and a chord that this angle is 1/2 of that. Or you may find something that says this this angle is 1/2 of these arcs, but neither of those really fits what you're trying to do here. Okay, so stop and look for a minute. Really look through it. Okay, I'm going to go on because you can stop. All right, now when you look at this, you might remember and you might find on your theorem list where it says if you have an inscribed angle like this, like DBC is an inscribed angle, that angle B is 1/2 of the arc CD. And you have another inscribed angle right here at angle C. Angle C is 1/2 the arc AB. Well, isn't that a coinky-dink because we have arc DC mentioned right here and arc AB mentioned right there. Okay, so you can write down angle B equals 1/2 CD and angle C equals 1/2 of the arc AB. And you know that's true because it's the inscribed angle theorem. Okay, so now we've got something about adding stuff. Okay, so how can you get to add up AB and CD, and how's that related to angle 1 in any way? Well, let's mark the angles that we're dealing with. I'm going to mark them with a different color. Okay, and we're dealing with this angle here and this angle here. All right, what do you know about those angles? Well, you can see in here that there's a triangle that includes those angles. And what relationship does angle 1 have to angle B and C? Now you're going to have to look way back on your theorem list, back a long time ago, and you might want to stop the tape again and just see if you can figure this one out. That's a triangle there, and angle 1 is an exterior angle. Now, I'm just going to go to a different part here. Okay, you've got this triangle that looks sort of like this, and let's see, this is B, and this is C, and this is angle 1. Okay, you might remember that there are 180 degrees in the triangle. Is that an A right there? No, there's nothing there. It goes up to A right there, but there's nothing right here. Okay, when you look at that triangle, you may remember there are 180 degrees in a triangle. And there are also 180 degrees in this straight angle here. So you may remember that angle 1 plus this equals 180. And this plus these two equals 180. So you might remember that angle 1 has to be equal to angle B plus angle C. Okay, that's where we get our little plus thing in here. Because right here we have that angle B is equal to something and angle C is equal to something. So that's where our plus is going to come from. Okay, so we're going to write in here an angle 3, number 3, angle 1 is equal to angle B plus angle C. And that's the exterior angle theorem. And then the fourth thing, the fourth thing would be then to substitute that in. Angle 1, take out the angle B and put in 1/2 CD equals 1/2 CD. And angle C is equal to 1/2 AB plus 1/2 AB with the arc sign over top. And that is by substitution. Now you can put SUBST, but not just SUB, because substitution or subtraction both start with SUB. Alright, but that's not really how they have it written. They have the 1/2 out here. Okay, so we're going to factor out the 1/2 or undistributed it, as one very brilliant student said. And that should be the measure of plus the measure of AB. And that is undistribution or factoring. Factored. Okay, so there's your proof.
Anyone else have anything you need to tell me before I continue giving out answers? Are we good to go now?
Yes.
All right.